Hi, Assalamualaikum warahmatullahi wabarakatuh. We are from Group 8 from tutorial TSP1. We going to present our assignment for course TST0925 Physical Chemistry and Organic. In this video, we are going to present our answer for questions related to Chapter 7 Haloalkane.
This is our group member.
Okay, for Task A, synthesis and reaction of organic compounds. This is our question. We have gotten question for question 8.
The question is, give IUPAC name and classification of isomer. For this question, we need to do the expanded structure. For A, the Cl will be bonded to C and the another 3 will be bonded to CH3. The name will be 2-chloro-2-methyl-propane. And then for B, the Cl will be bonded to the last C, and the first one is CH3, the CH2 3 times, and then Cl. The name will be 1-chlorobutane. And then C, the Cl will be bonded to the second carbon, CH3, CH2, Cl, CH2, CH3. The name is 2-chlorobutane. Next, we need to do reaction equation involving 2-chloro-2-methylpropane, the most reactive isomer, with KCN and ethanol under reflux with respect to SN1. For reaction mechanism, SN1 have two steps. Step 1 is formation of carbocation. This C is electropositive and Cl is electronegative. This bonding electron have two electrons that will be attracted to Cl, which is electronegative. So this bond between C and Cl will be break and we will form carbocation and anion, with the rate of reaction is low. For step 2 is nucleophilic attack on carbocation. This carbocation will react with Cn negative, which is nucleophile. This nucleophile will attack carbocation because Cn negative is rich of electron, and then they will be forming new bond like this, and it will be the fast rate of reaction. Next, we need to arrange ABC according to their activity toward SN1. So the answer is B, C, A, toward the ascending order. So A is the most reactive. Why? Because the tertiary haloalkane have tertiary carbocation. Tertiary carbocation is the most stable, so we assume it is most reactive. If stability of carbocation increase, the reactivity in SN1 is also increased. A followed by C and followed by B. C is secondary haloalkane and B is primary haloalkane.
For the next question, we have been asked to draw the structure and give IUPAC name of isomer D. From the previous question, we already know that structure D is isomer for chlorobutane with the molecular formula C4H9Cn. Okay, so we can determine that structure D is 1-chloro-2-methylpropane, and how to draw it is like this. And then in the next sentence, it says that structure D, when react with magnesium in anhydrous ether that we bring the same meaning with dry ether, will produce alkyl magnesium chloride as the structure E, and then hydrolyze to become structure F, which is the alkane. This means structure D will involve in preparation of Grignard reagent. So 1-chloro-2-methylpropane, when reacts with magnesium in dry ether, will produce the isopropyl magnesium chloride, and then isopropyl magnesium chloride being hydrolyzed to produce 2-methylpropane. Okay, so how to draw structure E is like this, and to draw structure S is like this. Then in the next sentence, say that structure D can be involved in elimination reaction when react with ethanolic potassium hydroxide under reflux to produce structure G. Mean structure D will involve in dehydrogenation that eliminate its chlorine and hydrogen when react with ethanolic potassium hydroxide under reflux to produce 2-methyl propene. Then the next sentence states that structure D can treat by sodium metal in ether solvent to yield a symmetric alkane that possesses 2 tertiary carbon. It means 1-chloro-2-methyl propane can involve in Woods reaction that can produce a longer alkane that will double its carbon. So it means 1-chloro-2-methyl propane when been treated with sodium metal in ether solvent will yield a 2,5-dimethyl hexane. Next, in last sentence it says that structure D can be hydrolyzed with aqueous sodium hydroxide under reflux producing alcohol I, and it shows that structure D will be involved in nucleophilic substitution reaction to produce the alcohol. It means chlorine in the alkyl halide will be substituted with hydroxide. So, 1-chloro-2-methyl propane can be hydrolyzed with aqueous sodium hydroxide under reflux producing a 2-methyl propanol.
Okay, let's continue with task B, which is inert component. Our group choose pumpkin. And related Quranic verse is from Surah As-Saffat, Surah number 27, ayah 146. A'udzu billahi minasyaitonir rajim. Wa anbatna alayhi syajaratan min yaqtin. And we caused to grow over him a ground pumpkin plant. Functional group presented is hydroxy compound. One active component that exists in pumpkin is cis-H3N1-ol. This compound is naturally produced in the pumpkin. This compound is the main contributor to the aroma of freshly cut pumpkin, and that's why when we cook pumpkin we can smell the sweet smell. Composition of pumpkin is pumpkin contains 1.76 protein, 2.7 of fiber, 49 calories. For vitamins and minerals, vitamin A, vitamin C, vitamin E, riboflavin, potassium, copper, manganese, thiamine, vitamin B6, folate, pantothenic acid, niacin, iron, magnesium, and phosphorus. Pumpkin also contains 0.17 gram of fat, 12 gram of carbohydrate, and 0 gram of cholesterol. Or in other words, pumpkin doesn't contain cholesterol. And benefit of pumpkin. Pumpkin have high antioxidant content that helps protect from disease, high in vitamin C and vitamin A needed for collagen production, eye health and immunity, and also packed with potassium that helps to lower our blood pressure. And chemical reaction for the active compound in pumpkin, which is H3N1-ol, can be esterificated in the presence of hydrogen sulfate and heat when react with H3NOE acid to form H3-anyl H3NOE. So that's all from our group. If you have any question regarding this topic, don't hesitate to ask us, or maybe you can directly ask Dr. Huda or Madam Ruby. That's all from us. Thank you.